Foundations of Amateur Radio. The idea of building a crystal radio occurred to me a little while ago. I committed to building one, supplies permitting, before the end of the year. I can report that I now have a crystal radio. It works, as in, I can hear a local AM broadcast station, and it took a grand total of 3 components costing a whopping $2.50. Before I get into it, this isn't glorious AM stereo, or even glorious AM mono. This is scratchy, discernible, unfiltered, temperamental radio. But I built it myself from scratch, and it worked first time. Before I start describing what I did and how, I'm letting you know in advance that I'm not going to tell you which specific components to buy, since your electronics store is not likely to have the same components, which would make it hard for you to figure out what would be a solid alternative if you didn't understand the how and the why of it all. So, disclaimer out of the way, my aim was to build a crystal radio using off-the-shelf components, without needing to steal a razor blade, shave a cat, sharpen a pencil, or any number of other weird contraptions. Not that those aren't potentially interesting as life pursuits, though the cats I know might object strongly. I wanted this to be about learning how this thing actually works, without distraction. I set about finding a capacitor and an inductor combination that made a resonant circuit, with a frequency range that falls within the AM broadcast band. If you recall, you can make a high-pass filter from either a capacitor or an inductor. Similarly, you can make a low-pass filter from either component. If you line up their characteristics just so, you'll end up with a band-pass filter that lets the AM broadcast band pass through. Now notice that I said range. That means that there needs to be something that you can adjust. In our case, you can either adjust the inductor or the capacitor. Technically, you could do both. My electronics store doesn't have variable inductors, so I opted for a variable capacitor. The challenge becomes, which variable capacitor do you select with which inductor? I used a spreadsheet to show what the bottom and top range for each capacitor would be if combined with each inductor. This gave me a table showing a couple of combinations that gave me a range of resonance inside the AM band. The formula you're looking for is the resonant frequency for a parallel LC circuit. Take the inductance, multiply that by the capacitance. Then take the square root, multiply it by pi and again by 2. Then take the inverse and you'll have the resonant frequency. You'll need to pay attention to microhenry versus millihenry and picofarad versus nanofarad, and you'll also need to confirm that you've got kilohertz, megahertz, or just hertz out the other end. Otherwise, you'll end up several orders of magnitude in the wrong spot. If you do all that, you'll likely end up with a couple of combinations of inductor and capacitor that will do what you want. Then, when you head to the electronics store, you'll find that the stock you're looking for is end of life and that the color coding on them isn't right. But if you manage to navigate that swamp, you'll come out the other end with a few parts in your hands. Final bit you need is a diode. It acts as a so-called envelope detector. I'm not getting into it here, I'll leave that for another time, but a Schottky or germanium diode is likely going to give you the best results for this experiment. Wiring this contraption is pretty trivial. Start with joining the inductor and capacitor to each other in parallel. They'll act as the LC circuit. You can change the resonance by tweaking the variable capacitor. Then attach a long antenna wire to one end and an earth wire to the other end. Finally, connect the diode and an amplified loudspeaker in series between the LC antenna end and the LC earth end, and your radio is done. For my experiment, the loudspeaker has a built-in amplifier. It's an external PC speaker with a power supply. I also had to keep my hand on the antenna to create enough signal, since essentially I'm a large body of water, great for being a surrogate antenna. The unexpected thrill of hearing a local announcer coming through into my shack from 3 components lying on my desk was worth the anticipation. Highly recommended. What are you waiting for? I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.